Welcome, stargazers, and welcome to our journey through the cosmos. Tonight, we're fixing to explore the wonders of the Messier Objects, a collection of celestial objects that'll leave you starstruck. But before we set out on this cosmic adventure, let's take a minute to tip our hats to the man who made it all possible, Mr. Charles Messier. Born in France back in 1730, Charles Messier wasn't your typical Frenchman. While others were busy with baguettes and berets, young Charles was captivated by the night sky. See, his daddy worked for the court, and one day, a fiery comet blazed across the heavens. Little Charles was smitten, and that, my friends, was the start of a lifelong love affair with the stars. Now, back then, telescopes were about as common as a snowball in summer. But Charles, he got his hands on one and started studying the heavens. He was particularly interested in comets, those elusive wanderers of the cosmos. Night after night, he'd scan the skies looking for anything that moved against the backdrop of stars. Charles had a knack for this comet hunting business, and he quickly made a name for himself. He discovered comet after comet, earning the admiration of astronomers all over Europe. But along the way, he kept stumbling upon these fuzzy patches of light that looked an awful lot like comets but weren't quite right. These celestial imposters, he realized, were causing quite a stir in the astronomical community. You see, back then, finding a comet was like striking gold. It brought fame, recognition, sometimes even a royal pension. But these fuzzy patches of light, they were throwing a wrench in the works. Astronomers would spot them, think they'd hit the jackpot, only to realize they'd been fooled by a celestial fake. Well, Charles, he got tired of these cosmic pranksters. So, he decided to do something about it. He started keeping a list, a catalog of sorts, of all the fuzzy objects he came across that could be mistaken for comets. He figured if he could warn other astronomers about these celestial imposters, they wouldn't waste their time chasing after them. Little did he know, this list of his would become one of the most important documents in the history of astronomy. Now, Charles wasn't just content with jotting down a few notes on a piece of parchment. He was meticulous in his observations, carefully recording the position, size, and shape of each object he encountered. And he didn't stop with just a handful of objects. By the time he was finished, his catalog included over 100 celestial wonders. From glowing clouds of gas and dust to tightly packed clusters of stars, Messier's catalog captured the diversity and grandeur of the cosmos. Each object was given a simple designation, M1, M2, M3, and so on. And these M numbers became shorthand for some of the most breathtaking sights in the night sky. Now, you might be wondering why Charles was so focused on these fuzzy objects in the first place. Well, remember, he was a comet hunter at heart. And these fuzzy patches of light, they were a nuisance, a distraction from his true passion. But in trying to avoid them, he ended up creating a roadmap to some of the most fascinating objects in the universe. And that's the funny thing about science. Sometimes the greatest discoveries are made not by seeking them out directly, but by following a different path, by exploring the unknown with an open mind and a curious spirit. Charles Messier, the Comet Hunter, may not have found all the comets he set out to find, but in the process, he stumbled upon a treasure trove of celestial wonders that continues to inspire and amaze us to this day. So join me, space explorers, as we embark on a journey through the cosmos, following in the footsteps of Charles Messier. We're going to explore the wonders of his catalog, from the fiery remnants of exploded stars to the glittering stellar nurseries where new suns are born. We'll start with M1, the Crab Nebula, a cosmic masterpiece painted across the canvas of space. Get ready, folks, because we're about to embark on an unforgettable adventure through the cosmos. Now let's mosey on over to our first Messier object, M1, more famously known as the Crab Nebula. Picture this, a giant star, much bigger than our own sun, burning bright for millions of years. But even stars don't live forever, and this one's time was coming to an end. When it finally ran out of fuel, it couldn't hold itself together any longer. It collapsed in on itself, its core compressed with unimaginable force, and then, boom! It exploded with the power of 1 billion suns, sending shockwaves rippling through the cosmos. That, my friends, is what we call a supernova. Now, this ain't your ordinary cloud of dust, y'all. The Crab Nebula is what we call a supernova remnant, and it's a sight to behold. It's located about 6,500 light-years away from us in the constellation Taurus, the Bull, and it spans about 10 light-years across. That's a whole lot of cosmic real estate. When we look at the Crab Nebula through a powerful telescope, we're seeing the aftermath of that ancient supernova. The glowing gas and dust are still expanding outward, propelled by the immense energy of the explosion. And it's not just any old expansion, folks. It's a chaotic, swirling dance of light and color. You see, the supernova didn't just fling out material in a uniform sphere. It created all sorts of complex structures like filaments, knots, and bubbles, as the expanding gas collided with the surrounding interstellar medium. It's like a cosmic Jackson Pollock painting, a masterpiece of chaos and beauty. And it gets even more interesting. At the very heart of the Crab Nebula lies a tiny, incredibly dense object called a neutron star. This little fella is what's left of the original star's core, compressed down to the size of a city by the force of the supernova. Now, neutron stars are some of the most extreme objects in the universe. They're so dense that a teaspoonful of neutron star material would weigh billions of tons here on Earth. And they spin incredibly fast, some of them rotating hundreds of times per second. The neutron star at the heart of the Crab Nebula is no exception. It spins about 30 times per second, and as it spins, it sends out beams of radiation from its magnetic poles. These beams sweep across space like a cosmic lighthouse, and when they happen to point towards Earth, we detect them as pulses of radio waves. That's right, folks. The Crab Nebula is home to a pulsar, a rapidly rotating neutron star that emits pulses of radiation. It's like a cosmic beacon reminding us of the incredible power and violence of a supernova explosion. And the story of the Crab Nebula doesn't end there. This cosmic cloud is still evolving, still expanding, still putting on a show for us here on Earth. Astronomers continue to study the Crab Nebula to learn more about supernova, neutron stars, and the life and death of stars. All right, stargazers, we're now entering the realm of globular clusters. These ain't your average star clusters. Giant cosmic snow globes chock full of stars. First stop is M2. It's 37,500 light-years away in the constellation Aquarius, with over 150,000 stars in a region and 175 light-years across. And M2 is just the tip of the iceberg. Next is M3, even bigger and brighter, 33,900 light-years away in Canes Venatici and home to 500,000 stars. These clusters are like families bound by gravity for billions of years. Now, you might be wondering what makes these globular clusters so special. Well, for starters, they're old, and I'm talking ancient, like older than the Great Pyramids old. We're talking about stars that were born when the Milky Way galaxy itself was just a baby. You see, most of the stars we see in the night sky belong to what we call the Milky Way's disk. That's the flat spiral-shaped region where our sun hangs out. But globular clusters, they're different. They hang out in the Milky Way's halo, a vast, spherical region that surrounds the disk. And because the stars in globular clusters formed so early on, they're made of mostly hydrogen and helium with very few heavier elements. That's because heavier elements are created inside stars and then scattered into space when those stars die. So the stars in globular clusters, they're like a time capsule, giving us a glimpse into the early universe. Now, imagine you could travel back in time and visit one of these globular clusters. You'd be surrounded by hundreds of thousands of stars all packed together in a relatively small space. The night sky would be ablaze with starlight, a sight more dazzling than any fireworks display you could imagine. But here's the thing that really gets astronomers excited about globular clusters. They're like giant laboratories for studying stellar evolution. You see, all those stars in a globular cluster, like the M4 shown here, they formed at roughly the same time, from the same cloud of gas and dust. That means they have similar ages and compositions, making them ideal for studying how stars evolve over time. It's like having a giant experiment with hundreds of thousands of stars, all in various stages of their lives. Astronomers can study these clusters to learn about how stars form, how they age, and how they eventually die. They can also use globular clusters to study the structure and evolution of galaxies, including our own Milky Way. And as if that weren't enough, globular clusters are also home to some of the most exotic objects in the universe, like blue stragglers, millisecond pulsars, and even black holes. These objects challenge our understanding of physics and push the boundaries of what we thought was possible. We've talked about globular clusters, those tightly knit families of stars. But there's another type, more open to new experiences. Open clusters are like free-spirited cousins. They're younger, forming from giant clouds of gas and dust, less densely packed like jewels on a velvet cloth, found within the disk, often in spiral arms, young, energetic, and full of potential. Now, before we dive into the world of open clusters, let's take a look at one more globular cluster, just to round out our appreciation for these celestial treasures. This time we're journeying over to the constellation the Serpent, to visit M5, a dazzling sphere of ancient suns, located about 24,500 light-years away. Now, M5 is a real showstopper, folks. It's one of the oldest known globular clusters, with an estimated age of around 13 billion years, meaning its stars were among the first to ignite in the Milky Way. Just imagine the stories those stars could tell if they could talk. When you gaze upon M5 through a telescope, it's like peering into a cosmic jewelry box. Over 100,000 stars twinkle within its boundaries, their light blending together to create a shimmering sphere that seems to float against the backdrop of space. But M5 isn't just a pretty face, folks. It's also a hotbed of astronomical research, as astronomers study its stars to learn more about stellar evolution, the history of our galaxy, and the fundamental laws of physics. Now let's turn our attention to those free-spirited open clusters, starting with two celestial gems that grace the summer sky, M6 and M7. Located in the constellation Scorpius, these clusters are a treat for both naked-eye observers and telescope enthusiasts. M6, the butterfly cluster, is a beautiful gathering of about 80 stars. Its name comes from its resemblance to a butterfly. Nearby we find M7, the Ptolemy cluster, a dense gathering of about 100 stars. Named after the famed astronomer Ptolemy, it's been a favorite for stargazers ever since. Now, space explorers, we're fixing to leave the world of star clusters behind for a spell and journey into the heart of a cosmic masterpiece. M8, the Lagoon Nebula. Imagine this, a giant cloud of hydrogen gas stretching over 100 light-years across, lit from within by the brilliant young stars it has spawned. Now, the Lagoon Nebula is what we call an emission nebula, which means it's giving off its own light, like a cosmic neon sign. Interspersed with that glowing hydrogen gas are dark lanes of interstellar dust, like shadows cast against a bright backdrop. Now, the Lagoon Nebula ain't just a pretty face, folks. It's a dynamic, ever-changing environment where stars are born, live out their lives, and eventually die. Within those dense clouds of gas and dust, gravity is hard at work, pulling material together and causing it to clump up. The birth of stars is a violent process, and the nebula is filled with shockwaves and stellar winds, sculpting the surrounding gas and dust into fantastical shapes. Now let's tear ourselves away from the Lagoon Nebula for a bit and journey back into the realm of globular clusters, those ancient sentinels of the Milky Way. This time, we're headed towards the constellation Ophiuchus, the Serpent Bearer, to visit two more of these stellar swarms, M9 and M10. M9, located about 25,800 light-years away, is a relatively small but densely packed globular cluster, home to an estimated 100,000 stars. Just a stone's throw away in cosmic terms, we find M10, another globular cluster, this one located about 14,300 light-years away. Well now, folks, after exploring those ancient globular clusters, let's shake things up a bit and visit a younger, livelier bunch of stars. We're headed over to the constellation Scutum, the Shield, to meet M11, also known as the Wild Duck Cluster. It's a swarm of about 2,900 stars, all huddled together about 6,200 light-years away. And when you see it through a telescope, it's easy to see why it got its name. Now let's mosey on over to another globular cluster, but this one's got a bit of a mystery surrounding it. M12 is a globular cluster also in the constellation of Ophiuchus. This cluster is located about 23,000 light-years from Earth. Because globular clusters like M12 have such high concentrations of stars, they often contain binary star systems, systems of two stars that are locked in orbit around each other. And now, folks, we've arrived at the granddaddy of them all, the king of the globular clusters, the one and only M13, also known as the Great Globular Cluster in Hercules. Located about 22,200 light-years away in the constellation Hercules, M13 is a breathtaking spectacle of over 300,000 stars, all packed into a sphere about 145 light-years across. M13 is so bright and prominent in the night sky that it can even be seen with the naked eye on a clear, dark night. Well, folks, after basking in the glory of M13, let's venture a little further out to meet another member of the globular cluster family, M14. Now, M14 might not be as flashy as its cousin M13, but it's still a sight to behold. We're talking about a ball of around 150,000 stars, all huddled together like a swarm of fireflies on a summer night. Now hold on to your hats, folks, because we're about to journey deep into the heart of our galaxy to visit M15, a globular cluster located about 33,600 light-years away in the constellation Pegasus, the winged horse. Now let's leave the world of globular clusters behind for a spell and journey to a place where stars are born, amidst a breathtaking tapestry of gas and dust. We're talking about M16, folks, also known as the Eagle Nebula, located about 7,000 light-years away in the constellation Serpens, the Serpent. And one of the most iconic features of the Eagle Nebula is a region known as the Pillars of Creation. Now prepare yourselves, because we're about to set course for a celestial spectacle that'll leave you breathless. M17, the Omega Nebula. Located about 5,000 to 6,000 light-years away in the constellation Sagittarius, the Archer, the Omega Nebula is a vast stellar nursery, a place where stars are born amidst a breathtaking tapestry of glowing gas and obscuring dust. The Omega Nebula gets its name from its resemblance to the Greek letter omega, omega, which kind of looks like a horseshoe or a swan with its wings outstretched. Now let's take a little detour from those grand sweeping nebulas and visit a smaller, but no less intriguing gathering of stars. We're headed over to the constellation Sagittarius to meet M18, a young, open cluster that's just starting to make its mark on the cosmos. Located about 4,900 light-years away, M18 is a relatively small and faint cluster, with only about 30 stars visible through most telescopes. And because it's so young, its stars are still relatively close together, their gravitational interactions shaping their movements and influencing their evolution. Let's journey back into the realm of globular clusters, those ancient sentinels of the Milky Way, to visit M19, a cluster that's been shaped by billions of years of cosmic forces. Located about 28,000 light-years away in the constellation Ophiuchus, the Serpent Bearer, M19 is a testament to the enduring power of gravity. Unlike most globular clusters, which are fairly spherical in shape, M19 is kind of squashed, like someone took a cosmic rolling pin to it. Astronomers figure this distortion is due to the cluster's interactions with the gravitational tidal forces of the Milky Way. Well now, stargazers, we're about to embark on a journey to a place where beauty and chaos collide, where stars are born amidst a swirling tapestry of glowing gas and obscuring dust. We're headed to M20, the Trifid Nebula, a celestial masterpiece that'll make you believe in the artistry of the universe. Located about 5,200 light-years away in the constellation Sagittarius, the Archer, the Trifid Nebula, is a stunning example of a star-forming region. Now, let's take a little detour from those grand, sweeping nebulas and pay a visit to a smaller but no less intriguing gathering of stars. We're headed to M21, a young open cluster still basking in the glow of its recent birth. Located about 4,250 light-years away in Sagittarius, M21 is a relatively loose and scattered cluster with about 57 stars. This cluster is a fascinating glimpse into the early stages of star cluster evolution. M21 is only about 4.6 million years old, mostly hot, blue stars that shine with a youthful vigor. Let's continue this journey into the realm of globular clusters, those ancient sentinels of the Milky Way. Here we have M22, shaped by billions of years of cosmic evolution, located in the constellation Sagittarius. M22 is one of the brightest globular clusters, visible to the naked eye. It was observed by ancient astronomers long before telescopes. Through a telescope, M22 is breathtaking, a densely packed sphere of over 100,000 stars. M22 is around 12 billion years old, one of the oldest in the Milky Way. Well, folks, we've journeyed far and wide across the cosmos tonight, from the fiery remnants of exploded stars to the stellar nurseries where new suns are born. We've peered into the hearts of globular clusters, those ancient relics of the early universe, and marveled at the delicate beauty of open clusters, those glittering swarms of stellar siblings. We've witnessed the chaotic beauty of emission nebulas, those cosmic canvases painted with glowing gas and obscuring dust. And we've pondered the mysteries of dark nebulas, those shadowy regions where gravity is quietly at work, shaping the destiny of stars yet to be born. And through it all, we've followed in the footsteps of Charles Messier, that meticulous comet hunter who, in his quest to chart the heavens, inadvertently created a roadmap to some of the most breathtaking sights in the cosmos. Now, I know what you might be thinking. That's a lot to take in, Crixus. My brain's about as fried as a catfish at a fish fry. And you know what? You'd be right. The universe is a big, complicated place, full of wonders that can boggle the mind and challenge our understanding of the cosmos. But here's the thing about astronomy, y'all. It's not just about memorizing facts and figures. It's about opening your mind to the possibility that there's something bigger than ourselves out there, something that connects us all, something that reminds us that we're part of something truly awe-inspiring. And that, my friends, is the true legacy of Charles Messier. He may not have found all the comets he set out to find, but in the process, he opened our eyes to the vastness and diversity of the cosmos. He showed us that there's more to the universe than meets the eye, and he inspired generations of astronomers to keep exploring, to keep asking questions, and to never stop marveling at the wonders of the night sky. Now, we've only scratched the surface of Messier's catalog tonight, folks. There are over 100 objects on his list, each with its own story to tell, each a testament to the beauty and complexity of the universe we call home. But even if you never get around to tracking down every single Messier object, I hope tonight's journey has inspired you to look up at the night sky with a renewed sense of wonder and curiosity. Because out there, amidst those twinkling stars, lie countless mysteries waiting to be unraveled, stories waiting to be told, and countless wonders waiting to take your breath away. So, the next time you find yourself beneath a clear, dark sky, take a moment to remember Charles Messier, that meticulous comet hunter who stumbled upon a cosmic treasure trove. And then, with a heart full of wonder and a mind open to the possibilities, just look up and let the universe amaze you. Now, I know what you're thinking. Hold on there, partner. You're not going to leave us hanging, are you? What about the rest of those Messier objects? Well, fear not, my friends, because this cosmic journey ain't over yet. We're just getting started. Stay tuned for part 2 of our Messier series, where we'll delve even deeper into the cosmos, exploring more of those celestial wonders that have captivated astronomers and stargazers for centuries. But until then, keep asking questions and never lose your sense of wonder. Because the universe, my friends, is a vast and mysterious place, and there's always something new to discover, just waiting for a curious mind to come along and unravel its secrets. So until next time, keep looking up.